I'm sure a lot of you work with this, you've gone through it a lot, and some of this was probably repetitive, but I always feel working with something like anhydrous ammonia, it's always good to have a review and make sure you're aware of all the ins and outs and everything that works for the Raven AccuFlow system. So we'll talk about the Raven AccuFlow system. Raven has been in the AccuFlow business since over the late 70s, over 30 years. So we've had a lot of experience with it, and we've worked with it with a lot of different toolbars and a lot of different scenarios. Just a couple things about anhydrous. This isn't a safety class, but I just would always like to remind people as we go through things. Always be aware of the danger of working with anhydrous ammonium. Make sure you use your goggles and rubber gloves when working with things. Have plenty of fresh water available, and also make sure whenever you're working with a system, always stand upwind with working around the equipment. Some of the characteristics quickly of anhydrous ammonia to always be aware of is that it irritates the skin and mucous membranes. At 50 parts per million, its odor is detected by most people. Maximum allowable concentration for an 8-hour working exposure is specified at only 50 parts per million. And anhydrous ammonia is fatal at 5,000 parts per million, which isn't very much. So always be careful when you're working around something with NH3. Some of the things we want to talk about with anhydrous ammonia is we know that NH3 or anhydrous ammonia is 82% nitrogen, 18% hydrogen, and to remain a liquid, the boiling point for any NH3 or anhydrous ammonia is -28 below Fahrenheit or -33 centigrade. We have issues when it's exposed to regular common temperatures that we work with. And so if we look at the pipe material that we use, we should always be aware of what we use in the system. We always want steel, and we want it to be Schedule 80 only. Schedule 80 can withstand pressures or ranges up to 350 psi, so that's why we recommend Schedule 80. We do not want brass, we don't want plastic, and we don't want copper. None of them are conducive to working with NH3. As an example, I want to show you just a quick picture of someone who used Raven's regular poly boom valves, perception shutoff on the end. This is what happened to those valves after only about 45 minutes of use. They don't last long, they're not going to work well, and it's very obviously a dangerous scenario to work with. One other thing, quickly at the very bottom there, NH3 must be a liquid in order to be metered. That's what we're trying to set for. That's our goal, is to keep that in liquid form to meter. We all know in all our high school chemistry and science classes, physics, which tells us that anytime you turn to a gas, the molecules are jumping and bouncing around all over, and it's much more stable when it's in liquid form. So that's our goal, is to keep it in liquid form, run it through a flow meter, and run it as we would running liquid through a flow meter in a sprayer. There's two ways to keep anhydrous in liquid form. Number one would be under pressure, as we see in the nurse tank. That keeps the NH3 pressurized and it feeds the system accordingly, but it is in liquid form. The cooler, therefore, because what happens is when it comes out of the pressurized situation in a tank and it gets exposed to the atmosphere, plus going through hoses causing friction, it starts to heat up. Gas will form within that NH3 mixture as it's coming out of the system. That is the purpose of the cooler, because we add additional cooling to the system and we return everything back to a liquid state to keep it below that vapor point. If we look at a system, we see that pressure loss is bad. Some of the things we have to look at, if we get excessive pressure loss as we're going through the system, is our system sized properly? Do we have the correct, if we have a 60-foot toolbar and we're putting on in excess of 200 pounds of N per acre, a single cooler probably is not going to be able to do the job, especially with the higher speeds that we're driving these days. So we may have to make sure we have the right size cooler to work with the toolbar that we're applying with. The second thing is to make sure when we set a system up not to have excessive elbows and T's. We want as straight a run or straight a shot coming from the tank as possible. Anything that makes that anhydrous bend and turn as it's going through and prior to the cooler causes excess friction, and therefore also causes more gas to form as we're going through. So the more efficient we can make that plumbing setup going through there is big and important. Also, consistent hose lengths. Big thing is anhydrous will always take the path of least resistance. So if we have hoses at different lengths, the anhydrous, as it's flowing through the system, will go to the shorter hose and we will be applying more. And this also goes into the area that we're looking at nowadays when we're putting sections on a system. When we have a splitter or divider on a system, even with 1-inch hose, and let's use for an example, if we have 3 sections on that toolbar, the ones going to the outer wings will require much longer hose than the center section itself. But if we just keep that center section only 6 to 8 feet and probably make those left and right outer sections 15 to 18 feet long, if we do not make them the same size, I guarantee you, you will have more application on that center section than you will the outside sections. So we want that even, so even though it's a pain to coil hoses up, even coming from your distributor or else going out to your manifolds, whether with the hoses out to the shanks or coulters, we still need them all the same length. And finally, pipe size changes. If we're coming from the tank to the cooler, if we're going to a larger pipe, if we go from a 1.5-inch hose to a 2-inch pipe, that's okay. However, if we go from 1.5-inch hose to a 1-inch pipe, conversely, that is not a good thing because that's narrowing it down, you're orificing it down, and you're causing it to cause more friction once again, and then we're going to run into issues with cooling, causing more gas to form. We generally like to recommend from tank to cooler, if possible, about a 15-foot length of hose. We know there's certain scenarios, like with the cedars with our customers up north, that goes beyond that. They probably don't put as high rates on, so that probably will help. But in general, we like to see about a 15-foot length, which is our recommendation from tank to cooler. So I'm going to show you just quickly as the super cooler itself, how it works, and I'm going to just use the non-vortex system because it's simpler. If we look, the main flow comes through the inlet of the cooler, goes through the center tube, goes out that center tube, and from there it drops down the bottom out to the flow meter, the valves, and eventually out to the toolbar. That's where it goes through. So as we go through that system, if you can see everything that's green, that's usually what fills up with the main flow of the system going out. Some of the NH3 comes back through a refrigerant line, and we use it as coolant. So that comes up through the little orifice and port that's right next to the main flow inlet of the cooler, and it comes through a long narrow tube and it expands into that outer tube. There's an area there, or a jacket area around there, that expands into that area, and it also goes out to the vapor tubes. As the pressure drops to near 0 psi as it's going into that outer jacket, the temperature will decrease to as low as 28 degrees below Fahrenheit. So what we're doing is we're basically orificing it down through this long tube, and we do have an orifice on the newer coolers, and when it expands or flashes, the temperature will actually cool and get down to negative 28 below Fahrenheit. What happens is that this cools those outer two tubes, those two inner tubes, inside the cooler itself, and it extracts the heat from the main flow of the NH3, and it reduces it back to a stable liquid. So any gas that may be forming through the main flow of the liquid coming through of the NH3 as it goes through, we extract any heat from that, and it returns back to gas in that form again. So if you look at that, we got that outer jacket, that's one expansion point. And the second expansion point is once it expands one more time into a large area, and that's in the vapor line area. That's about a 4-inch area at the end of the cooler, and then from there it goes out to the vapor tubes. One thing to know, when I talked about we want a 0 psi area, that is necessary. If there's pressure in there, it will not cool to that amount. When we run our lines out to the knives, we never want to tee them into the main flow. They have to be a separate exhaust point right on the shank itself, because if we tap into the main flow out of the knives, that causes back pressure into the system, and we will lose our 0 psi condition, and therefore we won't cool. So now when we go to the Vortex system, remember I talked about 2 expansion points. Well, actually we've added 3 more expansion points into the system. We have an orifice, we go to a 1/2 inch to a 1-inch line, and then we also have a T in there, in addition to the original expansion points of the outer jacket and the vapor area. So that 5 expansion points gives us more capacity in that single Vortex cooler as compared to what we've had before. Basically 60% more than the original original anhydrous cooler. So when we're determining cooler capacity, these are some things we have to look at and keep that in mind. What we want to do is take our maximum rate, multiply it times what we feel our maximum speed will be, and then take our implement width in inches or centimeters, but we have to have our rate times our speed times our implement width, not in feet. We have to have it in inches. That amount that we get, we have to divide by the factor number of 5940, or if when we're going in metric, 60,000. That will give us our pounds or kilograms of N per minute. We always remember we are figuring in pounds of N per minute, not pounds of total product. The coolers are ranked and rated in gallons per minute. So what we have to look for is we have to take it one more time. So we'll go back to what was saying that, once we've done the configuration of rate times speed times implement width, and we divide it by a factor number of 5940 for 60,000, 1 gallon of N weighs 4.22 pounds. So in order to figure out what a capacity of a cooler is, we divide the resulting number from the above calculation one more time by 4.22, because that's what 1 gallon of N weighs. When we get to that, our answer will be how many gallons per minute you are actually using. Keep in mind, as we go through the cooler capacities, we have the non-vortex cooler. That's the 30 gallon per minute cooler. That's the one we've used over the years. We still use and it's still available. Comes up to about 126 pounds per minute, or 57 kilograms per minute. Basically about 30 gallon per minute is what it is. Now if we go to a dual cooler system, which there's a lot of them out there as well, basically it is not just the dual capacity. You double the capacity of the two coolers, because we're still running it through one flow meter and one set of valves. So actually the capacity on that is probably about 40 to 45 gallons per minute. That's what you generally get, and we have to realize this is under good conditions, current conditions, and it's can be fluctuate, could be more if the temperature is up to 70 degrees, could be less if the temperature drops to 35, 40 degrees, could be a bit less. So keep that in mind as you're going through. It's just a starting point, and that's basically what we're looking for. Now, if we go to the AccuFlow Vortex and HP Plus, here's some things we have to look at. The Vortex itself, single Vortex cooler can exceed the amount on generally of a dual cooler system. That's up to 50 gallons per minute on the Vortex only. If we add the pump through an HP Plus system, that is 80 gallons per minute. For those of you wondering what 80 gallons per minute configures to, that would be, example would be a 60-foot toolbar applying 300 pounds of actual N, driving 9.3 miles per hour. So there's plenty of capacity we feel provided through either the Vortex itself or the HP Plus system. The nice thing about the Vortex, it's a smaller footprint than a dual cooler, and we designed it with some safety features in mind, enhanced diagnostics and serviceability, and it is ISO compatible. I'm not going to touch on those. I've talked about them in the past, but we'll just keep going. So just quickly on the AccuFlow Vortex HP Plus, it runs as a single product. When we go to HP Boost on the older system with a dual cooler and a pump, you always had to run it as separate products. You had to have your AccuFlow as one product. You had to have your pump as a second product. And therefore, what you would do is you would set a target rate of pressure, and when the system pressure was below what your target rate pressure was, it would tell the pump to kick in until the pressure was equal, and the pump would run accordingly. So that system basically was run on pressure. The HP Plus runs on flow instead. So when the control valve goes wide open and it still sees that we're not reaching correct rate, it will tell the pump to come in and turn on and compensate for that. That's why we can run it just as one product. We run it because of that. It's also it is run as a single fast close valve. Part of the reason for that is we have valve diagnostics, and what works with that is in the old system, if you're running a 440 with a fast valve system, what happens when you come around to the headlands, you turn it on, going back into the field, you open it up, the fast valve will go wide open, and it comes back and searches until it finds its correct rate point. On this system, through the node itself, we have the valve itself will feather itself open. It won't go wide open, so it actually works as a standard valve system. So therefore, we only felt we needed the fast valve only on the HP system. Now, it's compatible with different things. It's compatible with the Viper 4, the Viper Pro, and the Invisio Pro. It's compatible with ISO, but it is unable to operate in HP Plus mode with Raven consoles. That would be example of the 4400, 4600, 5000. In that case, the HP Plus would have to be run in HP Boost mode. We look at the flow meters, non-vortex versus the vortex system. There is a difference. They're both stainless steel construction. They both have the same capacity. The internals are exactly the same. There's nothing that's changed on that system. On the current flow meter, as far as the non-vortex, we use 1.5 NPT threads, and it probably takes in excess of 20 minutes to remove and reinstall the flow meter. For those of you who've had to work and take a flow meter out of a dual cooler system with the pipe wrenches, you know what a pain that can be. With the new flow meter design, instead of the 1.5 NPT threads, we have 1.5 groove coupling ends. What we do is you look at the bottom of the screen, we have groove lock couplings. They fit around the end of the flow meter. They have a internal gasket to seal, so it seals to the plumbing and to the flow meter itself. All it takes is the 7/8 wrench to remove. There's one on either side, and generally you can take the flow meter, remove it, and reinstall it in less than 10 minutes. We feel that that's a big help in serviceability. That's a big advantage. One quick note on when we say 0 to 20 gallon per minute range, and then I put behind there up to 90 gallon per minute. What does that mean? Well, 60 gallons per minute is the rate. What happens is when you use water to test it. All our flow meters are tested with water. Water weighs approximately 8.6 pounds per gallon. When we're running anhydrous through a system, it's much lighter. 1 gallon of total product weighs approximately 5.15 pounds. So that difference between the two compensates up, so that allows us to run up to 90 gallons per minute with that same ranked flow meter. So some of the things we want to look at with troubleshooting, you do not want more than a 5-pound pressure drop from your nurse tank to the cooler. That is desirable. Sometimes it can be more, but what we have to do is we have to measure the pressure loss from both static and operating conditions. What is static? Static is when you're standing still, you have your on-off valve on the system off, but your tank and cooler are all filled. That means it's charged. So the gauge on your cooler will assume the same pressure reading as the gauge on your tank. So that would be what we're looking at. So then when you apply, we should see what the pressure reading on that gauge is then. If it's more or exceeds more than 5 pounds of pressure drop, then with something we maybe should look at the plumbing or what's causing that issue, especially if our rate's starting to jump around and become erratic. Those are things we can look at, and we'll talk about what happens if our rate goes erratic and what we have to look at accordingly in a couple slides here. The other thing I want to talk about, and that's something we definitely deal with going into fall, is the cold weather application. There's always the fight between the pressure in the tank versus the lower temperatures. The simple part of physics with AccuFlow and NH3 is the fact that lower temperatures coincides and results in a lower pressure within your tank. And what happens is, as we're driving through the field and that the pressure is lower than what we're calling for as we go through the system, we're basically out driving the system. So when the weather gets cold, the pressure drops in the tank, and we were probably driving 7 miles per hour, 7.5, and now as we drive, the amount of speed and how much we want to apply is calling for it faster than what the flow and the pressure in the tank will allow for. So therefore, what's going to happen is we're going to get air bubbles going through the system, and your rate's going to start going erratic. A lot of times just slowing down a couple miles per hour can make a big difference. That can be a good troubleshooting tool. That's the first thing we should probably check, especially if the air is cold and conditions are good. I know that's not anything anyone wants to hear when you're applying out there to drive slower, but that's just the nature and physics of NH3. One way to combat that, and that's one of the reasons Raven came up with, is the pump system. The pump will compensate for that lack of pressure and build the pressure up in the system so you can maintain that desired ground speed that you want to do. So if that's an issue that you're running into with a larger toolbar, it's calling for it, and you can't reach the rate that you want to, especially in colder conditions, I would recommend you look and into going into a pump system with the HP Plus. So if we're looking at a system and if we are over applying, generally most of the time it's our settings. So make sure our speed is correct, that it's matching up what it should be accordingly. Make sure we've got the right amount of inches for our booms and the right sections. Make sure they're correct width and assigned correctly. And another thing to check is that meter cal. Make sure that you use the second line. A lot of times people look at it and they see that meter cal, it says on that flow meter for that AccuFlow, and it'll say 710, so they enter 710 in. Now that'll probably work in the Deere systems because they have on the GRC it will compensate, but in anything with Raven node or so, you have to use the second line. And and that number generally is anywhere from 168 to 173. If the tag is off, that is the numbers. I'd start in there, probably start at 170 and see what you can do. You can probably go down or go up a little bit to adjust, but that's the number we want to use. The trouble with going at 710 is it's rated in gallons per minute. So it actually, instead of putting on pounds per minute, we're trying to apply in gallons per minute. Therefore, the system, I've got guys call when I've been in tech support, they say I'm going wide open and I still can't reach my rate. Well, it's because you're trying to read in gallons. If you were trying to put 200 gallons, pounds per acre on, and you had it set at 710, you actually were trying to apply 200 gallons per acre, not 200 pounds. So if we set it back to 170, that's that 710 number divided by 4.22. Remember that? That's the weight of 1 gallon of actual N. That's how we arrive at that number, by the way. We put it at 168 to 170, put that in. Now we are putting in pounds of N per acre. If we are under applying, there's some things we should look. Once again, check our settings. Do we have our booms assigned correctly? Is their speed under what it should be? If it's like I talked about, is the cold weather conditions, could it possibly be that the weather's too cold and we have to slow up? The other thing that we can look at is there's something wrong with the cooler itself. Do we have something that's plugged, some obstruction going through the system? Those are things that we can look at. Let's go into more troubleshooting. Let's say our rate is 0. Well, what are the things we have to look at? If we have no rate, always remember the 3 basics to reach rate. This is anything on any Raven system, what we are to. We are a flow-based system, so what we have to look at is we have 3 inputs or 3 components we always have to be aware of. We need speed, we need area, which is the width of our booms, and we need volume, which is the reading through the flow meter. And if we miss any one of those 3, we will not get a rate. So if you get a 0 rate reading, always keep that in your mind, go back to basics. Generally, the 2 constants are your area and speed. One of the things you can do is check your area per hour. Area per hour gives you a combination of speed and your booms. Trying to go by process of elimination, you don't have to be applying. All you have to do is just drive. Have your master switch on. You don't have to be applying. Section valves or anything don't have to be on. Just drive. And if you get an area per hour reading, that tells you that your booms and your speed are correct. And so there's only one left, and that would be your volume. So then we check our volume per minute. So we should check the reading from the flow meter. Are we getting a rate reading? If we're not getting a rate reading, let's do a cable check. Let's conduct a voltage check. We go 5 volts power and signal coming from the console of the controller. And also we can do a short, no short test. That's a jump between the signal and the ground. So we look at that in the cable, and always remember our cable settings. We have the keyway at 12 o'clock. At 2 o'clock, our ground position. At the 6 o'clock position is our signal, and the 10 o'clock position is our power. So we want to go jump for a short, no short test between the 2 o'clock and 6 o'clock. If we're looking for power, it goes between 2 o'clock and 6 o'clock and 2 o'clock and 10 o'clock. We should see 5 volts both ways. If the cable is good, then we know everything is good going back to the machine or the tractor. Then we should maybe take a look at the sensor on our flow meter. While it's connected to the cable, and using the same settings we've used for the short, no short test, wave a magnet across the sensor while connected to the cable. If you do that, something should come up on your total volume, just as it does if you're doing the short, no short test. When you are putting that sensor back in, or if you have to replace the sensor would be bad, make sure the grooves and lines on the sensor are lined up with the flow of the flow meter. We don't want them off diagonal, we want them straight right on with the flow of the flow meter. And finally, do a flow meter mechanical check. If we're doing something and the sensor seems good, now we have to look at the flow meter itself. Could it be debris or turbine damage, bearing out, etc. So I've got a couple examples here. This is the sensor. This is the way it would look sitting on that flow meter. See those grooves or lines on there? They have to be in line with the flow of the flow meter itself. Now, if we're looking for debris or issues with going in the flow meter, this is what happens if you neglect to put the screen in the system. You can see these kind of chucks. Well, that impedes the flow and the spinning of the flow meter. The other thing I want to bring up is that this is on another system as well. If you look at the shaft on the flow meter, how that's wearing down. Now, what's happening here is the fact that operator always let his tanks run empty. So what happens, there's 2 bad things that happen when you run your tanks empty. Number 1 is obviously you're not putting a consistent rate on. But number two is the gas remaining or the pressure remaining in the tank will spin that flow meter way beyond what it should be able to handle. And when you spin it that much more, you start wearing the shaft down. This shaft is on its way to being sheared off, and we'd have to replace the whole turbine inside that system. We always recommend that you try and keep at least 5 to 10% left in your tank, so use that volume tank per minute reading, and as it counts down so the warning comes up, don't run your tanks empty, not only because of the poor application, but it's hard on the components in the flow meter. The other thing you do is when you put a system and you're testing it for air, does it flow through? Don't use an air compressor blowing it through the system. I talked to a guy a couple weeks ago. He said there's a guy at his co-op there. He turns it on and you can just hear the turbine scream when it goes through. That's a good way to wreck the bearing and the shaft on the flow meter. So make sure when you do that, you can check it for air leaks and you can keep the system closed around there. You know, go around the joints, probably use soapy water to make sure everything's all right prior to the season starting. But what you don't want to do is have the valves open and blow that through there. So if we get erratic rate, another thing is what should we do? So the first thing I would say is switch your controller to manual. We're putting that control valve in a manual position. It cannot move unless you actually make it move. And what we're basically doing is splitting the control of the valve versus the flow meter. So right now we're just working with the valve itself. If the rate becomes steady, check the control valve and its settings. So once you put it in manual and your rate level's off, then we know we got something going on with the control valve and what's happening here. If the rate is still erratic, we got some things to check. That means that we got some of the inputs going in to make a difference. So first of all, obviously, is your tank empty? That's the first obvious one. Make sure that we're not getting rate jumping around because of the tank being empty. Is it something with the speed? Is our speed jumping around? That's probably we have a poor connection. Depends what we're using for our speed input, but if that's inconsistent, that will affect your rate as well. Otherwise, let's look at our volume per minute. Is our rate jumping around? It's probably something to do with the flow meter or something that's causing that flow meter to read things erratically. So what's generally, I would say, the large majority of the time, if our rate is jumping around, it has something to do with what's going through the flow meter, and it's reading air bubbles and going on consistently. So the first thing, look at temperature versus pressure. If your conditions are cold, if it's in the morning or toward evening, just try slowing down, see if that makes a difference. That's the first and easiest thing to do. You don't have to get out of the tractor to do anything, just try that first. Secondly, is there excess debris in the strainer or the screen? Those are things we can look at as well. If we see a bunch of junk, especially we know when we start to season out, collects in the bottom of those tanks, those first time through with the tanks, a lot of debris can collect on that. A lot of debris in the screen causes excess friction. If you go back to what I was talking about before, excess friction in there causes more gas to form and probably would be more than the cooler itself can convert back to pure liquid. Avoid any excess friction that starts up. The other thing is, check your vapor tubes. Are we seeing vapor come out? We can look at the knives themselves. Are we seeing it come out of there? If we're not, I tell people a lot of times just pull the hoses off, the hose barbs right at the cooler, pull them off, turn the system on quickly to see if we're getting vapor coming out of there. If we're not getting vapor out, maybe we've got something internally going on with the cooler itself, some kind of internal cooler blockage. Is it a plug cooler orifice or is it a refrigerant line blockage? So if we look at this is the newer coolers, and these are all on this isn't just the Vortex Cooler. I would say for at least any cooler that's probably 4 to 5 years old, all has an orifice in it like that. So the orifice itself is screwed in with an Allen wrench. You can screw that out, and over time that may become rusty, but there's probably a .093 orifice. That's the standard orifice put in there. That's roughly about 3/16 of an inch. So if you have an 1/8 inch wire, you could put it up there and break that loose. Once that's broke loose, anything there, that should take care of what's going in the system. If you have the older coolers with the long 3/16 or .093 orifice all the way the length of the tube, you will have to take some kind of wire probably to go up in there and see if you can work the things loose if you're getting nothing out of your vapor tubes. That means there's an obstruction in the coolant line. Side note, don't be out in the field and you see that orange flag wire setting in the ground or tied on a fence post or other places. Don't use that rusty flag wire, because if things break out as you're trying to force it through, you're in trouble. The other thing is, like I said, look for the refrigerant line that connects to there. Is there an obstruction? Many times you can just take that loose from the bottom of the cooler and see if we're getting NH3 coming through into that system. It should be liquid mostly, and if it is, then we're okay on that as well. But those are all the things we should look at for erratic rate. All those points come into play. So if we're looking at valve issues, some of the things we look at for our control valve is the rate increases when you slow down and it decreases when you speed up. It's basically telling us that control valve is not moving. So what's going on here? Probably on the control valve is what we look at. Let's put it in manual. Check your increase or decrease switch or your button. Move it up and down. See if your rate will move by manually making it move. If the valve does not move, we'll have to check the cable voltage. Check the cabling that's feeding up to that valve itself. Make sure it's okay. If the voltage is good, more than likely it's a valve issue. Something may be stuck, could be a bad motor. Those are things all to check. If your section on-off valve will not open or close, once again, we better check our cable voltage. Always remember, there's 3 wires connected to your section on-off valve. You have your ground wire, and we have our constant 12 volts on our power wire, and then we have 12 volts on the signal wire when the switch is on. Just to explain the concept real quickly here, the constant 12 volts always wants to keep the valve shut, and I'm oversimplifying how this works, but if you keep this concept, then you get it how the valve works. When you turn the switch on and put 12 volts on the signal wire, that overrides it, puts 12 volts out to the valve and opens that section valve up. When you shut the switch off, 12 volts is pulled off the signal wire, and the constant 12 volts takes over and once again closes the valve. If you're using a fast valve and the valve won't shut, make sure you have it set, especially those using the 440s and 450s out there. Make sure it's set to C-FC, Charlie Frank Charlie. Always make sure that. There are a lot of guys who call, I've had over the years, and they had it set to just CF, control valve, and it would not close when you shut off your master switch. And they say, now what do I do? My valve is going wide open. I can't shut it down. What should I do? I don't want to run the tank out. What you do is put it in manual, and you take your increase-decrease switch, and you decrease it, and eventually that'll shut the valve. Once it's shut, then you can go back in, and you can change the setting back to CFC or fast close setting. So we got the valve pinouts. We got them for our on-off valves and our control valve. And if you take a look, these are all can be found on our ravenhelp.com website through our knowledge-based articles. All you have to do is hit on the top bar once you get to ravenhelp.com, knowledge-based articles, and type in the box NH3 valves, NH3 valve wiring. You'll be able to hit this tab and that'll come right up. That'll give you all the pinouts of the corresponding valves. You can also get it for the flow meter as well. Here's another issue. Guys will call in and say, well, NH3 is coming out of my vapor lines even with the valves off. I have them off, now what's happening? First thing I would look at is if it's a new installation, check your plumbing. Did you have that refrigerant line to a point that it's prior to your shutoff valve on your system? Many times guys will put a refrigerant line or put the on-off valves on their splitter or divider, and then they'll, on another point of that, they will also tie in the refrigerant line. Well, the refrigerant line is prior to the on-off valves, and so it just continues to loop and cycle through. So make sure that that refrigerant line is always after your on-off valves on your system. The other thing is, it could be that the internal O-rings are bad on the cooler itself. That's on that inner tube. You can replace that with an O-ring assembly or the gasket kit itself. That they are included in the gasket kit as well. So most of the times, those are the two things that happens. You're always thinking about it. If it's a new system, probably check the plumbing first. If it's a system that has worked and we're leaking, could be O-rings. Finally, the one we don't want to hear is if it's the O-rings are bad, you pull it out. O-rings are good, and there may be rust, especially for those who run N-serve through your tanks instead of through it via injection. Over time, that will corrode and rust the internals of that system more, so it can cause pitting on that inner tube or something like that, and so we'll get leakage and bypass as well. So those are all things we have to look for if it's coming out of the vapor tubes. The HP Plus settings, just quickly, those are things that come up as we set up the system. You select on your product control, you set that up as an HP PWM on your application mode, and all these settings should be there. They should automatically come up. Those are the initial settings on the node. Make sure you calibrate your pressure transducer. The easiest way to do that is disconnect it from the cable from the transducer itself. Then we know it's 0. Make sure you hit calibrate and you should be good to go. If we have to run our system in an HP plus boost mode, there's a couple things we have to look at. If we have like a 4400 or 5000 or a 2-valve system. Steps for setup, we have to go with 2 products. So product 1 we set up as a normal NH3 system. Then we go to product 2 and we select spinner RPM mode. And then we enter a product 1 meter cal of 99.99 and then we press OK. What we do then is we exit and restart the controller. We shut it down, start up again. Once we do that, the settings in product 2 should be there. And once again, make sure you calibrate the pressure transducer. Another place we want to look at if we're doing multi-section and we put our on-off valves out at the manifolds, that is a big advantage because what happens is we charge the lines. When we turn the system back on, we're right there to put it right out to the knife. We don't have to refill the system right from the cooler and across the whole bar. But the one thing we have to be aware of, when we have those on-off valves at the manifolds, that line between the on-off valve at your cooler, that is all full of anhydrous ammonia. And if you follow the lines, and if you do not have a check valve where it's located, where it would go out to the system, everything will go back into the refrigerant line and come out your vapor tubes. So when I talk about plumbing on a new system, that's something to look at as well. Also when you set those section valves out there. So therefore we need a check valve. That will prohibit the anhydrous in those charged lines from exiting out through the refrigerant line on the system. Things to look at generally as we're going through the system, if there's frost on there, or where could it be good, where could it be bad? If we're having rate jumping around, what do we want to look for? If we got frost on our strainer, that probably tells us, and around the emergency hand valve, that usually tells us we've got excess debris in the strainer, and the strainer may be plugged or not functioning correctly. So therefore, we make sure we shut the system down, bleed it correctly, and then we can take that apart and probably clean out the strainer. Another spot would be coming out of the outlet of the cooler itself. If we've got frost coming out of that prior to the flow meter, that's basically telling us we have some obstruction within the cooler. The vapor and exchange is not working. What you really have now is nothing more than a big expensive piece of plumbing on there because it's not converting back to pure liquid. So when it's coming out of there like that, not a good thing. What is acceptable is when it expands and go out to the toolbar from there and we start seeing frost on that. Once we've gone past the flow meter, the valves, etc., it's not wrong to see some frost on that expansion on that T. The other place is to look at is the vapor tube port, not only where the vapor tubes are, but that whole little spot. So if you're running correctly through the field, it is okay to see about 4 inches on the end, right by the inlet of the cooler. That's where the vapor tube section is. That's where we're expanding. So that's common and it's normal. So what's good and not good, that's what we're looking at. At the end of the season, when we store the AccuCooler, we do, if possible, especially if running N-Serve through that with your tanks, make sure we coat that, if possible, with kerosene or fuel oil to prevent corrosion. That's not always the easiest thing to do. Sometimes people will take their refrigerant line and they will probably blow some out. That system will up in there, otherwise they can pull the end of the cooler off and they coat the system with that as well. Keep that in mind if we're running N-Serve through the tanks. So now we'll go on to injection. There's a couple things here. On an anhydrous system, we need an inline mixer and we do need a check valve. We don't want anhydrous going back to the injection point if we're putting N-Serve or nitrogen stabilizer on. On a sprayer system, we put it in the main or carrier line, not necessary with anhydrous because of the pressure of anhydrous does not allow the nitrogen stabilizer to go back into the system. We do have a new inline mixer, which is kind of nice. Everything's stainless steel, including the baffles. It's got a weldment bracket, so it's for easier to install. A lot of times you have it and you don't know where to tie onto. We've got a bracket for that. And then it's also got weldment ports and a point of injection on there, so you don't have to do the extra plumbing in the line as well. So that's all part of the convenience of using this new inline mixer. When we're wiring, going back, especially with the old sidekick consoles, because it's not a CAN communication, make sure you go directly to the battery, not to the power bars. Go directly to the battery. We want sufficient amp and volt and current draw for the pump itself. We look at the old sidekick console. There's 3 connections on there. We got the small 2 at the lower left, the tach generator cable, small 2-pin connector. We have a round 3-pin, which is for the metering sensor, similar to what a flow meter is. And then on the upper right there where it says the power cable. If we're checking power to the console, and for the pump itself, we're checking the cabling. When we run the system and we run the speed of the pump, we pulse voltage through the ground wire. So to get a true reading of voltage and power to the pump, we have to ground a frame. So check on your red wire for power and ground a frame to make sure you got a good 12 volts to make the system run. If the pump is running wide open, more than likely a lot of times it's the tach generator. Something we have to look at. If we can't raise or lower the pump, it runs wide open no matter what. Take a look there. Go to the cabling outlet from the pump itself, and with the pump running wide open, and check the voltage. We should see a minimum of 9 volts. If we're not seeing that, anything less, that means it's a bad tach generator and has to be replaced. If we get no flow reading at all, then we have to look at the metering sensor. That's that round 3-pin connector. Keep in mind the rate is read by motor revolutions, not flow on an injection pump. We calculate the speed, the width of the boom, and the rate in ounces per acre, and we tell the system and we tell the pump how fast the motor has to turn. And we are reading the motor revolutions, not the flow of the chemical going through the system. So keep that in mind. On the Sidekick Pro, we do away with the tach generator and the rate sensor. Now we use a high-resolution encoder. They seem to be very reliable. We've not had many failures, although they can fail from time to time. But those are things that are gone with the new Sidekick Pro. So on the pump, it's going to be the same, whether it be Sidekick Pro or the old Sidekick console. And you have your 3 components I want to talk about. You have your intake valve, your discharge valve. Chemical comes through there. The piston goes back and forth. It's a positive displacement pump. So we have 2 intake valves on either side. On the bottom, 2 discharges on the top the same way. And as the chemical flows back and forth, it pushes the shuttle with a little ball and a magnet on either side. In the middle, there's a spring. They go back and forth. The flow makes that move back and forth. Well, that motion back and forth will read the flow of the system. And what happens is it passes by the rate sensor. Every time it goes by the rate sensor, the light flashes and it sends a message that the shuttle is working. So that's how we make sure we have good flow going through the system. If one of the intake or discharge valves were plugged and there wasn't flow coming from the one side, it would not be pushing that shuttle back and forth. So therefore, we would only be getting half a rate, and we'd be getting a flow alarm because the sensor is not reading the movement of the shuttle and the light would not be flashing. So that's a good way, if we're getting a flow alarm when you're doing the troubleshooting, is to take a look. Is the red light flashing on the sensor? If it is not, that's something to look for, and then we may have to double pull those intake or discharge valves to see what's going on. So if we take a look at the flow, this is how it comes through quickly. It comes on the bottom, goes through the intake valve, the piston pulls through, and as the piston is pushing out to the top to the discharge valve, on the opposite side it's sucking it in, and that motion back and forth causes the system to continue to go, and that's why you hear the back and forth motion when the pump is working. And that also causes that shuttle to work as well. So if we do get a flow alarm, one of the things we can look at, is it a bad check valve, or could it be, if we're running NSERV, which can get gooey and gummy, especially if it gets cold, make sure that that shuttle is going back and forth in, that it's got free motion. Those are all things we have to look at to make sure everything's working right. So like I said, if the channel's plugged, the light flashing, or is it the check valves that could be bad, damaged or dirty. If the pump runs erratically, check for voltage, make sure we got on the power cable for either kind of pump. We might be plugged or dirty. Check the correct wiring for the correct voltage as well. If we get a vacuum alarm, there's a couple things we can look at. We should look at make sure the strainer on the system is okay. Maybe we have a 3-way valve turned in correctly. We could have a collapsed intake hose, or the chemical outlet in the bottom of the chemical tank could be plugged as well. One other thing, we do not want the pump itself to be more than 2 feet higher from the outlet of the chemical tanks. If there's in excess of a 2-foot lift, you've got to find another location, because it has to draw up more than 2 feet, you probably will get a vacuum alarm. So keep that in mind as well. If we're under applying, there's several things to look at. Injection check valves possibly could be dirty. It could be an air leak in the system, could be air in the chemical. Could be a plug strainer once again that's not allowing it to flow freely, and maybe the chemical itself is too thick. Those are things we look at for under applying. If we're over applying, as I said before, on most systems, maybe we have to go back and look through our settings, make sure that they are correct as well. As far as maintenance goes on the injection pumps, obviously first of all check the manual, check the strainer, make sure we have one in there. That is an absolute necessity. For the small internal parts on the pump, we do need a strainer on there. And what we always tell people, if you're using something like N-Serve, we tell everybody when the season is over, flush it out with petroleum-based system, because that's what N-Serve is. Flush it out with kerosene or fuel oil. And if you're putting it in cold storage, use 50-50 antifreeze. We feel 50-50 is better than RV, because in cold conditions, RV will turn to slush. And secondly, 50-50 lubricates the seals and O-rings much better, keeps them in better condition. So when we come around to the prior to the season of application, that is if we are using N-Serve, we tell everybody that is when we should put a new seal kit in. There's 117-015-9987. It costs right at $50. They have seals for each individual check valve, for on the piston itself, and then on the big O-ring that fits the head to the pump itself. Keep that in mind. If we're using N-Serve, just a side note, don't flush it out with water. Water is not compatible with N-Serve. We want a fuel-based system. Keep it in mind also, if the temperature is going to drop at night, don't leave it inside the system. That'll flush it out if it's going to get below freezing, because it will turn to gel or crystallize. So make sure you flush it out with either kerosene or diesel fuel. Get that through the system, because that'll save a lot of time taking the pump apart the next morning when things aren't working correctly. We do have an addition for the Sidekick Pro, which is the rinse assist system. It's a 3-way valve. Just by the push of a button, the 3-way valve will open up to the flushing agent in a separate tank. It'll pump the amount that desired through the pump itself. It'll run the cycle when the pump will shut off, and the 3-way valve will return to the original location to the chemical tank. That's all done with a push of a button, and it's available on all our systems with the Sidekick Pro. As far as the Sidekick Pro goes, we have our Diagnostic Lights. The nice thing about the Sidekick Pro also is the fact versus the old Sidekick. The old Sidekick, you had to have a lot of knowledge of what makes the pump run, how it goes. We have an error come up with Sidekick Pro. You'll see it on the screen. You'll be able to tell you what to look at and zero in what's wrong. So we have the 5 diagnostic lights on there. The first one is the logic power. The second is high current power that powers up the system. The next one is micro. If it flashes once per second, we're making good CAN communication. Otherwise, it'll flash 4 times per second if there isn't good CAN communication. The next one is the flow switch state. It'll flash for every revolution of the motor itself. The other one is when we're in the calibration mode, that it'll flash then. Finally, the internal switch. So when we calibrate, we have the calibrator on the Sidekick Pro. Push the plunger down. We push calibrate on our screen on the console. We go back and we look to see it's okay, and if we want to run it one more time, instead of having to go way back up in the cab and redo it, all you do is push the plunger down and take a pliers, wrench, etc., something metal, wave up and down one time, and it'll recalibrate. So that saves a trip back and forth on that.